Bismillahirrahmanirrahim. So in the next 1 hour or so, we'll be talking about and we'll be finishing optimization, because this is not the course of optimization. हम यहाँ discuss तो कर रहे हैं, but we are discussing very core values of optimization. So we'll be finishing up with whatever is left of optimization. It was a very brief overview, and then we'll be moving on to further topics. And today we also have our first guest lecture, Mr. Zishan, Engineer Zishan Khan. So he'll be joining us in about an hour's time or so. और फिर हम उनके साथ देखेंगे इंटरेक्शन कैसा रहता है. He'll be talking about something known as quality function deployment, QFD. A very analytical technique, a very good technique to know about the defects and quality in our organization. And he has worked on QFD in PTCL since long, so he has got a vast experience. So हम उनकी experience से फ़ायदा उठाएंगे. Okay, today we'll be talking about something known as MDO. It's a step forward in optimization, a step forward in linear programming. हमने पिछली क्लास तक डिस्कस किया था what is LP. We talked about optimization. We talked about how to build an optimization model through objective functions, through constraints, और उसमें हमने एक examples भी की थी, and then I'll also give you an assignment also as well. Today we'll be talking about furthering that knowledge of optimization towards a system. हम systems optimization की बात करेंगे, and we're talking about optimization of different systems and subsystems. So पहले हमने optimization की problem जो किया था, उसमें we talked about optimization of a single situation, optimization of a situation, and we were not actually going further than that particular situation. लेकिन आज जो हम बात करेंगे वो बात करेंगे optimization of a system. System में क्या होगा? There will be various subsystems. And every subsystem will have its own optimization model. ठीक है, हर सबसिस्टम का जो मॉडल होगा उसमें अपना ऑब्जेक्टिव फंक्शन होगा, अपने कंस्ट्रेंट्स होंगे, एक्सेट्रा एक्सेट्रा एक्सेट्रा. सो एवरी सबसिस्टम हैज टू बी लिंक्ड विद सम कॉमन कंस्ट्रेंट or with some common objective function. So that is what is MDO, multidisciplinary design optimization, in which you are combining various disciplines to form an optimization model of a complete system. पूरे system का optimization model आप कैसे बना लेते हो?
You will do the optimization of each subsystem.
You will try to do the optimization of each subsystem, yet separately. Yet what you are looking at is that how you can combine those models through common parameters, through common constraints, to form an overall holistic optimization model of a system. So concept वही है, methodology वही है, तरीक़ाकार वही है, लेकिन अब क्या हो गया है कि our area has expanded. अब हम एक सिस्टम लेवल से सब सिस्टम लेवल से सिस्टम लेवल की तरफ जा रहे हैं. So this is what is known as MDO, or multidisciplinary design optimization. So let's first of all talk about what is MDO. और उसके बाद I'll give you some examples from the daily engineering disciplines जहाँ MDO हुई है, और then I'll be leaving you with an MDO और जिस पे मैं आजकल काम कर रहा हूँ, और मैं expect करूँगा कि आप उसको देखें और get some inspiration if possible from that particular project which I'm doing, और उससे फिर अपने ये खुद एक optimization model build करें. So today you'll be having your second assignment as well. Okay, so आज हम MDO को देखते हैं. Okay, first of all, जैसे हमने कहा था कि sorry.
So you expect so much time on this optimization, and you are building that model. You expect us to do it after one.
And you will do it. that is my expertise. Okay, so what we are trying to start from is something known as system compartmentalization. Once you are talking about a system, you want to compartmentalize it, or you want to distribute in various subsystems, or in other words you want to disintegrate the system into various subsystems. तो जब तक आप उसको disintegration ठीक नहीं कर रहे होगे, you are not going to get an MDO or an optimization model of the complete system. ज़रूरी क्या हो गया? How you actually disintegrate your system into different subsystems, and how explicitly and how clearly you disintegrate your system into subsystems. Subsystems आपके मौजूद होते हैं हर सिस्टम में, but the thing is, or the beauty of it is that how you can actually disintegrate it explicitly, or how vividly can you see subsystems in a complete system. That is known as system compartmentalization. As in this slide मैंने कुछ example भी दिए. For example, अगर आप देखें तो at system level, name of a system is launch vehicle. subsystem is propulsion, then element is SRM, and within that element you have an ignition device, and within that ignition device you have an igniter. So this is an example of the compartmentalization taking place in a launch vehicle. Okay, well, what is SRM? Any ideas what is SRM? Solid rocket motor. Yeah, rocket motor. Solid rocket motor. So how you see how this system is compartmentalized, how this system has gone from one launch vehicle towards the part level. अब होगा क्या, once you are trying to compartmentalize everything, हमने optimization पढ़ी हुई है. What we will do is कि आपके अब optimization models जो होंगे अब part level के अलग constraints हैं. Part level के there are different constraints, different objective functions. For example, maybe at part level you are trying to minimize the weight. So objective function is weight minimization. So अगर आप part level को देखते हो तो you are looking at part level, you say that for all parts you are trying to minimize the weight. For example, this is the objective function, this is the objective function. But if you are talking about component level, अगर आप component level पे देखते हो, this might not be the objective function. Weight minimization, maybe it is one of the objective function, लेकिन हो सकता है कि efficiency comes into play or another factor comes into play. So उसका क्या मतलब हो गया कि your objective function is changing. जैसे जैसे आप move कर रहे हो in compartments, objective function changes, the constraints are changing. So the question is how to combine those objective functions towards a very global objective function, and how to combine those constraints into a global set of constraints. This is what is meant by systems or MDO or multidisciplinary design optimization. इसमें आप सारे disciplines को मिला के एक overall holistic optimization model बनाते हो, या कोशिश करते हो बनाने की, जिसमें कि there are universal constraints and there are universal objective functions. So this is where the world is moving. We were talking about system compartmentalization. So मकसद ये है हमारा कि how to combine these subsystems and how to combine the optimization model of every subsystem in order to get a holistic or universal optimization model consisting of universal constraints and consisting of common objective function. Okay, an example of system compartmentalization. For example, if you look at some satellite system, इस तरह उसमें space segment है, ground segment है, user segment है, and again फिर उन्होंने space segment को किस तरह मज़ीद divide किया है, ground segment को divide किया है और user segment को divide किया है. Has anybody one of you gone in project management? आपने किसी को है तजर्बा? उसमें एक चीज़ होती है, उसे कहते हैं WBS. नाम सुना आपने इसका? Work breakdown structure. So it actually looks like a WBS. अगर आप देखें तो उसमें भी क्या होता है, उसमें डिसइंटीग्रेशन हो रही होती है हर चीज़ की. So it actually looks like a WBS अगर आप इसको उसके साथ एनालॉजी देना चाहें वर्क ब्रेकडाउन स्ट्रक्चर के हवाले से. ओके, सो दिस इज़ हाउ यू एक्चुअली कंपार्टमेंटलाइज अ सिस्टम. और आप देखें तो हर डोमेन का अपना एक ऑप्टिमाइजेशन मॉडल होगा, और हर ऑप्टिमाइजेशन मॉडल जो है दैट हैज़ टू बी कनेक्टेड टुवर्ड्स अपवर्ड्स एंड डाउनवर्ड्स, ताकि आपका एक स्पेस सेगमेंट का ऑप्टिमाइजेशन मॉडल बने. देन यू हैव ए मॉडल फॉर द ग्राउंड सेगमेंट एंड देन यू हैव ए मॉडल फॉर यूजर सेगमेंट, और उसको कंबाइन करके यू विल हैव एन ऑप्टिमाइजेशन मॉडल फॉर अ होल सैटेलाइट सिस्टम. सो दिस इज़ व्हाट इज़ MDO. ठीक है, दिस इज़ द एक्सटेंट ऑफ MDO. और उसमें कुछ एग्जांपल्स दूंगा बिकॉज दिस इज़ द कटिंग एज ऑफ ऑप्टिमाइजेशन राइट नाउ. इस हवाले से आजकल जितनी डेवलपमेंट्स हो रही हैं आपकी हाईटेक इंडस्ट्री में, एरोस्पेस इंडस्ट्री में, सैटेलाइट इंडस्ट्री में, मिसाइल इंडस्ट्री में, इंजीनियरिंग मैनेजमेंट के हवाले से कहीं भी ऑप्टिमाइजेशन हो रही है, MDO इज़ राइट नाउ द कटिंग एज ऑफ द डिज़ाइन ऑप्टिमाइजेशन और ऑप्टिमाइजेशन इटसेल्फ. फॉर एग्जांपल लुक एट दिस. अगर आप इफ़ यू लुक एट वेरी हाईटेक इंडस्ट्रीज, सो you have programs, within program you have several projects, within projects you have systems, within systems you have segments, then elements, then subsystems, assemblies, sub-assemblies and parts. हम जो बात कर रहे हैं वो यहाँ तक बात कर रहे हैं. We are talking about MDO till this point, till systems level. We are not talking about the optimization of projects and of course not talking about optimization of the programs. एक प्रोग्राम में बहुत सारे प्रोजेक्ट्स भी हो सकते हैं, बट वी आर टॉकिंग अबाउट सिस्टम्स लेवल तक हम बात कर रहे हैं. सो हाउ टू डिकम्पोज अ सिस्टम? You have to define crisply inputs and outputs of each module. अगर आपने systems को decompose करना है, the best way is you look at a subsystem and you look at the parts. You should know two things: the inputs and the outputs. These are the two primary criteria जिसकी बेस पे आप फैसला करेंगे कि आपने कहाँ तक उसको compartmentalize करना है. Meaning is once you are clear about something in respect of the inputs and in respect of the outputs, you can stop there. You can stop to compartmentalize right there and then. आप disintegration उसको वहाँ तक करें, छोटे level तक, जब तक कि आपके inputs and outputs clearly define ना हो जाए. For item, of course, for a component, for a subsystem and for a system. So the basic criteria is कि आप inputs and outputs को कितना clearly define कर सकते हैं. जितना आप crisply define करेंगे उतना अच्छा आपकी compartmentalization होगी. And of course it comes with the experience. ऐसा नहीं है कि एक दफ़ा से आप सीख जाएंगे. It actually comes with experience and working with many systems and with many subsystems. वहाँ से आप सीखते हैं कि how to compartmentalize. It's a trial and error. ऐसा नहीं है कि एक दफ़ा से ही आप इस चीज़ को देख के सीख जाएंगे. ब्लैक बॉक्सेस का मतलब ये है कि आप देखते हैं कि कौन कौन सी ऐसी चीज़ें हैं कि जो अभी आपको डिफाइन नहीं हो रही. ब्लैक बॉक्स इज अ टर्म विच इज़ यूज्ड इन विच योर इनपुट्स एंड आउटपुट्स आर नॉट नोन. देन यू गो फर्दर इनटू दैट ब्लैक बॉक्स जब तक कि आपको इनपुट और आउटपुट क्लियर डिफाइन नहीं हो जाते. सो फर्स्ट ऑफ ऑल यू हैव टू, फॉर एग्जांपल इफ यू टेक एनी सिस्टम, इफ यू टेक अ कंप्यूटर सिस्टम और यू टेक अ डिमांड एंड सप्लाई सिस्टम, अगर आप सप्लाई चेन की बात करते हैं, और यू टेक अ सिस्टम ऑफ कॉन्ट्रैक्ट्स, किसी भी तरह का सिस्टम, वो प्योर इंजीनियरिंग सिस्टम भी हो सकता है, वो नॉन इंजीनियरिंग सिस्टम भी हो सकता है, वो इंजीनियरिंग मैनेजमेंट सिस्टम भी हो सकता है. सो यू एक्चुअली डिकम्पोज इट इनटू ब्लैक बॉक्सेस, मीन्स दैट वेरी बिग एंटिटीज. फॉर एग्जांपल इफ यू टॉकिंग अबाउट अ सप्लाई एंड डिमांड सिस्टम, सो यू एक्चुअली डिकम्पोज इट इनटू ब्लैक बॉक्सेस. कौन कौन से ब्लैक बॉक्सेस हो जाएंगे इसमें? एनी एग्जांपल्स? सप्लाई एंड डिमांड की बात कर रहे हैं, सप्लाई चेन की बात कर रहे हैं. व्हाट ब्लैक बॉक्सेस आर देयर? For example, supply of raw material, for example, then demand by customer, okay, then intermediaries, for example retailers or whatever. So there can be 3 black boxes. उसके बाद जब आप इसके डिकम्पोज करेंगे तो then you will actually go till that level जहाँ आपको input और output clear ना हो जाए. That is the smallest level of decomposition. इस तरह जब आप इंटरमीडिएट्स की बात करेंगे, यू विल गो टिल लेवल जहाँ के इनपुट एंड आउटपुट क्लियर ना हो जाए. अगेन इफ़ यू गो टू डिमांड बाय कस्टमर, आप वहाँ तक जाएंगे जहाँ तक आपको इनपुट और आउटपुट क्लियर ना हो जाए. सो यू हैव टू क्रिस्पली डिफाइन इनपुट्स एंड आउटपुट्स एट एवरी लेवल, तब आप जाके इस सिस्टम को डिकम्पोज कर सकते हैं. इट इज़ पॉसिबल बट इट इज़ नॉट लाइकली, बिकॉज या तो ये हो सकता है कुछ जगहों पे हो जाती है. फॉर एग्जांपल आप एयरक्राफ्ट सिस्टम को देखते हो एंड यू आर सीइंग कि जनाब इंजन जो है वो रोल्स रॉयस बनाएगा. सो इनपुट्स एंड आउटपुट्स वहीं से क्लियर हो गई क्योंकि आपने एक चीज़ को आउटसोर्स किया हुआ है. सो इट इज़ पॉसिबल वंस यू हैव आउटसोर्स्ड अ कंप्लीट सिस्टम टू अनदर मैन्युफैक्चरर. फॉर एग्जांपल इंजन या प्रोपल्शन सिस्टम किसी और ने बनाना है, तो अब ये एक सब सिस्टम है पूरे एयरक्राफ्ट में, तो ये जो सब सिस्टम है वो भी है, वो तो आएगी, वो आपको मॉडल डेवलप करना पड़ेगा उसका. लेकिन यह है कि आपको इनपुट्स एंड आउटपुट्स पहले से क्लियर होगी. फॉर एग्जाम्पल रोल्स रॉयस में गिव यू जनाब की इनपुट कॉस्ट क्या है, उसके बाद उसके वर्किंग आवर्स कितने हैं, उसके बाद फैक्टर ऑफ सेफ्टीज़ कितनी हैं, तो आपको इनपुट्स मिल जाएंगी आराम से. ये आपको आसानी पैदा हो सकती है वहाँ. So this is another example how to decompose the system. So for example, I have given you example of submarine. अगर आप submarine के लिहाज से देखें तो you can decompose it into structures, estimation and sensing, communications, power generation, life support systems, navigations, etc. etc. So depends upon the complexity of system कि आप उसको कहाँ तक decompose करना चाहते हैं. So वही बात आ गई कि the more complex the system is, the more difficult is analysis. जितना आप complex system होगा उतना analysis उसका difficult होगा. वही बात आ गई, how many elements are there in a system, what is the relationship, what is the interaction, and what are the states of those interactions. These are very important. Interactions क्या होते हैं? What are interactions? In a system किस तरह के interactions आप experience करते हैं? फॉर एग्जाम्पल अगर आप एक गाड़ी के सिस्टम के तौर पे लेते हैं, व्हाट आर डिफरेंट इंटरेक्शंस विच यू एक्सपीरियंस? किस तरह के इंटरेक्शंस हो सकते हैं? पहला इंटरेक्शन जब आप इग्निशन करते हो, सो देयर आर 2 systems coming and interacting with each other, or 3 systems maybe, or 4 systems. So these are interactions between subsystems. अब गाड़ी का एक ignition system है, एक fuel system है, एक engine है, ignition system है. So all of those systems are interacting to produce one common objective. So this is what is meant by interactions. So जितने interactions ज़्यादा होंगे उतनी ज़्यादा complexity बढ़ेगी, जितने ज़्यादा एलिमेंट ज़्यादा होंगे उतनी ज़्यादा कॉम्प्लेक्सिटी बढ़ेगी, जितनी रिलेशनशिप ज़्यादा होगी उतनी ज़्यादा कॉम्प्लेक्सिटी बढ़ेगी. रिलेशनशिप इस होता है कि वन सिस्टम इज रिलेटेड टू अनदर विद अ कॉमन, यू कैन से कॉमन एलिमेंट. फॉर एग्जांपल योर इग्निशन सिस्टम इज रिलेटेड टू योर फ्यूल सिस्टम थ्रू सम कंपोनेंट, दैट इज रिलेशनशिप. इंटरेक्शन ये है कि एक्टिव रिलेशनशिप इज इंटरेक्शन. अगर आप एक्टिवली रिलेशनशिप को, इफ यू आर ट्राइंग टू एक्टिवेट दैट रिलेशनशिप, देन इट इज इंटरेक्शन. हो सकता है कि रिलेशनशिप रहे लेकिन डॉर्मेंट रहे, बट अगर एक्टिवेशन आ जाती है रिलेशनशिप में, देन इट इज इंटरेक्शन. ये सब आपको डराने के लिए दिए हुए हैं. इसका कोई मकसद नहीं. ओके, सो लुक एट सिस्टम कॉम्प्लेक्सिटी. जितना कॉम्प्लेक्स होगा सिस्टम उतनी ज़्यादा उसकी ऑप्टिमाइजेशन या MDO जो है, दैट विल बी कॉम्प्लेक्स अफेयर. फॉर एग्जांपल, इफ देयर इज अ पेंसिल, then there are different components, and if there is a space shuttle, then of course there are many subsystems involved. For example, let's look at our favorite helicopters. Very complex system. As said by someone, helicopters don't fly, they beat the air into submission. So you know, very complex systems, और उसमें आप देखें कितने ज़्यादा interactions होंगे. And look at the level of complexity, and look at the level of MDO if it takes place in this sort of a system, जिसमें कि they are very complex system, और जिसमें कि you have to actually come up with a holistic optimization model. Analysis of a system, again taking example of a rotorcraft. You see, there are different ways in which you can analyze a system. अगर आप उसको उसकी एयर स्पीड के लिहाज से एनालिसिस कर रहे हो, then optimization model will be different. If you're trying to analyze a system through the fuel economy, then optimization model will be different. If you're trying to analyze a system through weight, again the optimization model will be different. So यहाँ तक हम 2 चीज़ों पे पहुँच गए हैं. Let's summarize. पहली चीज़ तो ये है कि MDO is a combination of optimization, different optimization model of different subsystems. Number 1. Number 2, very important. MDO also depends upon the point of view of optimization. आपने subsystems को मिला तो लिया, but what is your point of view? Why? Because your point of view will determine that what objective function you are going to select. For example, if you are viewing at a system from fuel economy point of view, so your objective function will be very different than if you are viewing a system from another point of view. So systems optimization और subsystem optimization is very important, लेकिन उसके साथ साथ important चीज़ ये भी है कि आपका point of view क्या है, because your point of view will determine that what sort of objective functions you have. अगर आपके point of view change होता है, you will have a different set of objective functions and maybe a different set of constraints. So you have to define that those viewing glasses, as you have 2 viewing glasses. So you have to define that viewing glass through which you are trying to see the system. सारे सिस्टम को आप किस viewing glass से देख रहे हो सकता है कि आपका, for example, if you are viewing a system from the view point of view that this is important for defense of a nation, so हो सकता है आपका optimization model cost minimization model ना हो, because cost को तो आप देख ही रहे हो उस वक्त. ठीक है, so objective function is different then. So that point of view is very important once you are trying to form a holistic objective function of the whole system. That is there.
That means for the same system you could have different models.
Different models. You can have different objective functions.
Objective function.
Yes.
Whereas another person may have another
objective function.
Yet another objective.
Yes, exactly. So you see, if you see modern aircraft of today, objective function is to minimize noise or minimize the or gain the fuel economy. Maybe. So if these are the 2 objective functions, तो फिर आपका पूरा जो optimization model है, that is totally different. Then if you are trying to view the aircraft from a safety point of view or from another point of view, उसमें होती है फैक्टर ऑफ सेफ्टीज, लेकिन आपका पॉइंट ऑफ व्यू जो है वो चेंज कर देता है आपके टोटल सिस्टम्स के ऑप्टिमाइजेशन मॉडल. दैट इज व्हाट आई एम ट्राइंग टू से. Okay, so this is what it is. It's a systems designer's nightmare because of the difference in point of views. Somebody is saying some constraints in his or her own language, and somebody is saying his or her constraints or objective functions in another language. So problem क्या आ जाता है कि आपके point of views different होते हैं. And the thing is that how you can actually come to a common point of view to define a common objective function. This is most difficult in any MDU or in any multidisciplinary design optimization project. This is the most difficult part. Okay, so this is where it is. Over here, the arrow people, the structures people, and the controls people, they have all come together to define a common objective function. So you see, अब objective function जो है वो बजाय इसके कि different point of views का different हो, now you have a common objective function, and that is to actually check the deformations or to check the bending stresses at wing root. So now this is the common objective function. Subsystems बहुत सारे थे, उन्होंने अपने अपने analysis किए, but now they have gained a common objective function. So this is how you develop a model. You start a process, you create objectives, constraints and design variables, जैसे कि हम पहले भी कर चुके हैं, अब सिर्फ उसमें सिस्टम लेवल पे ला रहा हूँ. That's what it is. Then you have a set of governing equations. Then you define your master table. Master table is that table which is actually giving you master or very you can say vivid parameters, जिसको कि आपने violate नहीं करना once you are trying to put on the constraints. That is a master table. Then you define modules. हर module को आप क्या करेंगे? You will actually go for the design optimization of that module. Then you will write the codes. Then you will integrate the modules. Then you will have a benchmark for each module. और उसके बाद आप कोड्स को टेस्ट भी करेंगे, वैलिडेट भी करेंगे. इटरेशन हो रही है. What is fidelity? Fidelity क्या होती है? Iteration to improve fidelity. What is fidelity? आपने सुना होगा, it's a high fidelity model, it's a low fidelity model. You must have heard this word. Fidelity is actually the detail. Detail, or the level of the level of content which you have. High fidelity models are those models which have very high or the minutest of details. And if you can actually you touch or you vary one detail, the whole model gets affected. So high fidelity models are models which are having high details. Level of details or level of abstractions are more. You can say fidelity are the levels of abstraction or the level of details. So once you are iterating to improve fidelity, it means that you are iterating to get more and more details into the model, more and more realistic details into the model. This is the iterative process which takes place. For example, you must have actually gone through this range equation. I think we went through it once we were doing our engineering in aerospace. So it's a typical range equation. But you see, the variables involved in this range equation, they actually represent very different point of views. For example, the velocity, maybe marketing people are actually concerned about the velocity of a certain aircraft, and they want to project it like this, that okay, it can go to Mach 2 or Mach 3. Marketing people are concerned with actually the maximization of velocity. The aero people are concerned with drag. They are concerned with minimization of drag. Propulsion people are concerned with the specific weight of the fuel. Or the structures people are concerned with the final to initial weight of wing ratio. So you will see many people are having different concerns in this one equation. In this simple one equation, there are 4 people fighting their hearts out for their own desired inputs. So how are you going to design a holistic optimization model of the system? This is a simple one equation, and you see there are 4 people or 4 point of views in this same equation. So this is the level of complexity to which the matter gets once you are talking about design optimization or optimization of a whole system. You can well imagine how many inputs are there and how many complexities are involved. So there are, if you talk about design optimization only, there are three basic categories in which you divide design optimization. I'll not go into detail because this is not again an optimization course. These 1 or 2 lectures are actually designated to give you some brief overview of optimization, although I feel that I have given you more than a brief overview. I have given you some depth also to this content as well. So one is trial and error, then is calculus based or non-expert system based, and then third one is AI based. Right now AI based is most prominent because you have different algos, you have different softwares in which you can use artificial intelligence to gain inputs and to actually come up with a holistic optimization of the whole system. So right now AI based techniques are there to be used. Trial and error is gone. Calculus based is very tiresome. Calculus based, it takes a lot of time. AI based intelligence networks are there, softwares are there, programs are there, you can use them. So let's take an example of Xerox copier. You know, photocopier was previously known as Xerox copier. उसका पहला नाम Xerox था, Xerox machine. अब वो उसे photocopy machine कहते हैं ना. पहले Xerox से जाती थी तो Xerox was there. So अभी भी Xerox copier ही कहते हैं, Xerox कहते हैं. So if you take an example of this photocopy machine, you see that how through correct design and through correct design optimization, they were actually able to save how many parts and what are the savings which they actually got because of the preemptive MDO, multidisciplinary design optimization technique, which they used. Okay, so comparing plastic parts with Japanese and European, they found that Japanese firms could produce a part for 50% less than American and European parts. So Europe attributed the cost difference to 3 factors. Material costs were 10% less in Japan, tooling and processing costs were 15% less in Japan, and remaining 25%, half of the difference, was attributed to how the parts were designed. So at design phase, they came up with a holistic optimization model of the whole system. अब देखिए इसमें भी different subsystems होंगे. So at design phase, once they came up with a holistic model of the whole system, they were able to save 25% of the costs, which were saved during the design of this simple Xerox copier. So this is the importance of MDO once you try to implement it in the design phase. Another example, aircraft design process. Again, we are going through aircrafts, but one can't help it if you see the level of abstraction in that aircrafts, because aircrafts are highly complex systems and their MDO has actually started from aircrafts. अगर आप MDO की practical uses की बात करें तो aircraft industry was the first one to actually adopt it and to make it part of their design process and the whole optimization process. So that's why we talk a lot about aircraft industry once we talk about design optimization. Oh, let's take an example of Boeing 787, the latest carrier of our time. So you see, it's a long-range, mid-sized, wide-body twin-engine airliner, and it seats around 210 to 330 people, depending upon the variants. So you see the level of abstraction which it has, or the level of details to which it is manufactured, designed to become the first production composite airliner with the fuselage assembled in one-piece composite barrel. Sections stand off the multiple aluminum sheets and some 50,000 fasteners used in the single aircraft. So you see the level of sophistication which this has, and it was all possible due to the optimization techniques, the artificial optimization techniques which they use at the design phase, and of course in the construction phase as well and the assembly phase as well. So these are the characteristics. The airplane uses 20% less fuel for comparable missions with today's airliners. So their objective function was reduction in fuel consumption. So they must have designed this airliner and they must have optimized the holistic model based on one factor only, and that was how to minimize the cost of fuel. And look at the speed. It will also travel at speed similar to today's fastest wide-bodied aircraft, Mach 0.85. So to marketing people, maybe this was one of the factors जिसके उन्होंने सारी चीज़ों को डिज़ाइन किया होगा. So the two different engine models compatible with 787 use a standard electric interface. अब there are two different engine models जो कि एक standard interface से Boeing 787 में लग जाते हैं. तो Boeing 787 can use engine from Rolls-Royce और engine from GE. और वो सिंपल यही है कि आपने एक उतारा और दूसरा लगाया. That's it. So this is the level of sophistication or level of design optimization which they have achieved. Okay, so these are some system requirements of that particular aircraft जिस पे कि वो डिज़ाइन किया गया. You see, there are subsystems, environmental subsystem, physical, functional, support, configurational, interface, constraints, and then quality. So this is actually I'm giving you these slides from the Boeing 787 project which actually happened. So ये वो slides हैं जो DMO की slides हैं जो कि 787 के लिए use होती हैं. So you see how the level of abstraction is done, subsystem level में convert करके, and they actually came up with a holistic design, optimized design. So these are the subsystems on which it was designed. Structural system, propulsion, fuel, hydraulic, flight control systems. 5 basic subsystems on which 787 was actually designed. So this is the optimization model. The objective was to increase the passengers capacity. So their objective was to increase the passengers capacity. So they had design variables. Some of them are there, सारे मैंने नहीं लिखे. Wing areas, fuselage dimensions, cargo capacity, thrust, engine efficiency, maximum fuel capacity, maximum speed, and then they had constraints, number of passengers. Well, how many number of passengers? The maximum number of passengers, that's a constraint. The maximum weight, that's a constraint. The human resource, that's a constraint. कितने आप बंदे लगाएंगे? ज़्यादा नहीं लगा सकते, because you can employ 2,000, 3,000 people. You cannot employ the 50,000 people for one project. The human resource. Then the cost, one of the biggest constraints. Actually, all the constraints come down to cost. All the constraints actually come down to cost. So this is the optimization model, or the systems optimization model of 787. That's how they defined the objective function or the problem statement for 787. Minimizing the objective function by controlling design variables while satisfying the given constraints requirements at given parameters. So इस तरह उन्होंने इस प्रॉब्लम को, सारे सिस्टम की प्रॉब्लम को डिफाइन किया, एंड दे केम अप विद 787. अच्छा, that's a trade off, because safety will require cost. Safety will require cost. For example, अगर आप चाहते हैं कि you want a parachute for every passenger, it will require cost. So that's a trade off, कि आप कहाँ तक कॉम्प्रोमाइज़ करते हो सेफ्टी को, कहाँ तक फिर नहीं करते. So once you are trying to go for any multidisciplinary design optimization or optimization of a system, you take care of 3 or 4 things. 3-4 चीज़ें बड़ी ज़रूरी हैं. वो क्या है? First thing is that you want your optimum to be here. That is known as constrained optimum, meaning it is satisfying all the constraints, and it is trying to maximize or minimize the objective function. That is a constrained optimum. Now this is a probabilistic optimum. This is just an idea. This is just an ideation that okay, this is just heuristics. लेकिन but इसमें problem क्या है? What is the problem with probabilistic optimum? According to this figure, problem क्या आ रहा है? क्या कह सकते हैं आप इसको देख के? कॉस्ट ज़्यादा लगानी पड़ रही है, और in addition to that, the problem is that it is maybe not meeting both the constraints or multiple constraints. ये डिज़ाइन स्पेस में तो है, this is called solution space, the feasible region of design. इसमें तो ये है, but this is not meeting the constraints. So probabilistic optimum is just for your reference. It is heuristic optimum which is there for your reference, but you are going to design or you are going to optimize the system based on the constrained optimum. Constrained optimum तक आपने जाना है, so that all the constraints are met. तो पहली कंडीशन क्या होगी सिस्टम ऑप्टिमाइजेशन के लिए? All the constraints are met, and then you are trying to maximize or minimize the function. जब तक constraints कंडीशन सारी नहीं मिलती और उसके बीच में अगर आप maximize or minimize कर देते हो फंक्शन को, that is not the maximum or minimum function, because constraints meet नहीं कर रहे.
It means that we have to remain closer to this heuristic optimum.
It means that you have to remain closer to the constraints. Constraints के साथ रहना है आपने. Constraints के साथ रहना है, because अगर आप constraints के साथ नहीं रहोगे ना, आप देखो ये यहाँ भी हो सकता है, ये यहाँ भी हो सकता है, ये इधर भी हो सकता है.
What is the use of giving this?
ये मैं बता रहा हूँ ना कि this is just an idea. दिस इज जस्ट एन आइडिया फॉर कि आप ये देखते हो कि सोल्यूशन स्पेस कहाँ तक एक्सपेंड कर सकती है. You have to try to see the width or range of your solution space. That's it. But you have to actually be very near to that optimum which is meeting all of the constraints. सारे constraints को meet करना बड़ा ज़रूरी है.
We cannot utilize that solution space. इसका reason थोड़ा सा ज़्यादा I would like to honestly optimum effect इस तरह की होती है कि इससे आपने design तो उसके लिए किया है, लेकिन because of the actual things on ground, you do not get that actual point. You go on to that point which probability है उस जगह पे आप जाके ऐड करेंगे. If you have must have designed the way say maybe where first not driver, it will live. लेकिन वो actually नहीं मिलेगी all right. तो जल्दी होगी वो probability उस जगह पे है because of the number of multiple extra reasons which have not been catered in. It is
So that will actually the
probability you will be there at the probabilistic level. There are more chances that you will be falling in this point. That is, but it would still be that
feasible range में होगा.
Not be the most optimal point. मतलब we are designing carefully in the opening that every quantity it should be with the percentage efficiency of 200. But we cannot go to that limit because of 200 is a fixed point. There are no other things जो कि fixed नहीं हो सकते. Like left out कह रहे थे कि मुझे इतने किलोमीटर मिलेगा नहीं मिलेगा. Right इतना किलोमीटर नहीं मिलेगा. Actually probability उस पे आ रही है. ये point आ रहा है जो आपके actual design में आ रहा है. Design आपको उसके लिए किया था जो कि constraint.
The ideal would have been this point, the constraint optimization.
Constraint, because वो आपके set of constraints जो है ना उनको meet कर रहा है. But I'll just further add to Dr. साहब, अब real situation में होता क्या है? Real situation में ये होता है कि okay, you have met the constraints and then you have maximized or minimized the objective function. But problem यहाँ आता है कि you can still see कि जो मैंने यार constraints बनाए थे, I can still redefine those constraints because solution space तो मेरे पास है. पैरामीटर्स मुझे ज़्यादा दे रहे हैं. सो वंस यू रीडिफाइन दैट कंस्ट्रेंट्स, तो फिर क्या होता है कि अगेन यू हैव टू कम अप विद अनदर ऑब्जेक्टिव फंक्शन जो कि उन रीडिफाइंड कंस्ट्रेंट्स को पूरा कर रहा है. सो इट इज़ एन इटरेटिव प्रोसेस. ऐसा नहीं है कि आपने कंस्ट्रेंट्स को मीट कर लिया तो योर डिज़ाइन योर ऑप्टिमाइजेशन इज कंप्लीट. इफ़ यू हैव डिज़ाइन स्पेस, और वो डिज़ाइन स्पेस कौन बताता है आपको? वो आपको प्रोबेबिलिस्टिक ऑप्टिमम बता देता है. बिकॉज वो वहाँ तक गया होता है जहाँ तक हो सकता है आप रियलिस्टिकली तो ना पहुँच रहे हो, लेकिन आपको पता हो कि यहाँ तक मैं इसको स्ट्रेच कर सकता हूँ. तो वहां तक पहुंचने के लिए यू हैव सम स्पेस लेफ्ट. तो अगर आप रीडिफाइन करते हो कंस्ट्रेंट को तो हो सकता है आप दोबारा उससे करीब पहुंचो. देन यू रीडिफाइन और फिर हो सकता है अगले स्टेप में आप उसके और करीब पहुंचो. You can redefine a constraint. For example, अगर आप weight constraint की बात करते हो, if you're talking about weight constraint and you say that it should not be greater than 800 tons, for example. Okay, so now this is a constraint, and if you see through your artificial intelligence methods that yes, you can go till 1000 tons. ठीक है ना, प्रोबेबिलिस्टिक ऑप्टिमम आपको कहता है कि आप 1000 टन तक जा सकते हो, लेकिन आपने कंस्ट्रेंट ये डिफाइन किया हुआ बेस्ड ऑन मेनी अदर थिंग्स. इसके पीछे भी तो बहुत सारे वेरिएबल्स होंगे ना. अब जब आप देखते हो कि आई हैव अ मार्जिन ऑफ 200 टन्स अवेलेबल विद मी. ओके, आई शुड नॉट गो 200 टन्स, मे बी आई कैन ऐड 50 टन्स. So it is a what if scenario. आप कहते हो okay, now if I actually add 150 tons over here, what will be my reshaped constraint will be. दोबारा से आप 850 पे प्लान करते हो सर, और फिर सारा चेंज करते हो, फिर आप देखते हो कि क्या आप कहाँ तक आते हो. So इस तरह you can redefine your constraints. Yes, you negotiate or you iterate with the constraints. So it is a continuous process. लेकिन जैसे मैंने कहा ना कि डिज़ाइन फेज में अगर ये हो जाता है और डिज़ाइन फेज में फ्लेक्सिबिलिटी आपके पास होती है, क्योंकि अगर एक चीज़ बन गई फिर फ्लेक्सिबिलिटी कम हो जाती है. सो व्हाट यू वांट टू डू इज दैट यू वांट टू एक्सपेरिमेंट विद कंस्ट्रेंट्स इन द डिज़ाइन फेज. एक्सपेरिमेंटेशन इज ऑलवेज डन इन द डिज़ाइन फेज. व्हाट अबाउट अनकंस्ट्रेंट? वेरी गुड. मैं कहता कि कोई पूछे इसको. अनकंस्ट्रेंट का पहले तो बताया अनकंस्ट्रेंट का मतलब क्या होता है. फॉर एग्जाम्पल, इफ आई गिव यू एन ऑब्जेक्टिव फंक्शन विच इज अनकंस्ट्रेंट, व्हाट डज इट मीन? कि उसमें कंस्ट्रेंट नहीं है. इसका मतलब ये है कि वो जो ऑब्जेक्टिव फंक्शन है वो इट इज़ नॉट बाउंड बाय एनी लिमिट. It is not bound by any limit. What you do is that if you, for example, if you are trying to have an objective function of weight, say, or for that matter drag or lift, which is unconstrained. For example, you say maximize weight is equal to something plus something, plus something, and you don't have any constraints. Those constraints are missing. Now, if you want to maximize weight depending upon those decision variables x2 x3 x3 whatever, अब क्या होगा कि आप डिसीजन वेरिएबल्स में इनपुट डालते चले जाओगे till you will reach the boundaries of these decision variables. Now these are not constraints. डिसीजन वेरिएबल की बाउंड्री कुछ और होती है. डिसीजन वेरिएबल की बाउंड्री ये होती है कि आप फॉर एग्जांपल आप कहते हो कि फॉर एग्जांपल x1 इज द वेट ऑफ सीट, फॉर एग्जांपल दिस इज द होल वेट एंड x1 इज द वेट ऑफ सीट. So what is the maximum weight of seat which is available right now? What is the maximum weight of that passenger seat जो कि अभी available है हमारे पास? वहाँ जाके आप रुक जाओगे. So this is not a constraint in itself, because ये constraint नहीं है, but this is the parameter जिसको कि आप overcome नहीं कर सकते. So in itself unconstrained functions will be maximized or minimized till you reach the parametric bounds of that decision variable. उस decision variable के parametric bounds को आप कहाँ तक टच करते हो, वहाँ तक आप इसको unconstrained को define कर सकते हो. But जब वो constrained हो जाता है, आप समझो कि जब आप constrained कर रहे हो तो आप क्या कर रहे हो? Once you are adding constraints to this thing, what you are actually doing is you are trying to give it a direction. आप डायरेक्शन दे रहे हो उस चीज़ को. So constraints are also those parameters which give direction to your model. अगर constraint नहीं होगा तो डायरेक्शन नहीं मिलेगी. It will be a directionless maximization or minimization, and it will continue till you reach the parametric maximas and minimas of that decision variable. Parametric decision maximas and minimas. तो parameters की हद तक आप जा सकते हो, उससे ऊपर आप नहीं जा सकते. अनकंस्ट्रेंट ऑप्टिमम ये कहीं भी हो सकता है. ये मैंने इसलिए रखा ना बिकॉज व्हाई इट इज अनकंस्ट्रेंट, बिकॉज इसमें हो सकता है कि आपका एक डिसीजन वेरिएबल बिल्कुल ही गायब हो सकता है दूसरा बिल्कुल गायब हो. सो दिस इज वन ऑफ द एग्जांपल. ये कहीं भी हो सकता है. यहाँ मैंने इसको इस एग्जांपल दी बिकॉज इट इज अनकंस्ट्रेंट, मीनिंग मे बी x1 इज नॉट कमिंग इनटू प्ले, और अगर यहाँ होता तो मे बी x2 इज नॉट कमिंग इनटू प्ले. ठीक है, दैट इज व्हाई इट इज अनकंस्ट्रेंट ऑप्टिमम. Okay, now this is the whole optimization model. Please have a look at this one and we'll discuss that. So this is the whole optimization model जो आपके पास होता है. There are different disciplines having inputs and outputs, or then you have an optimizer coupled with the evaluation of optimizer. Evaluation is done, as I told you in the previous lecture, by two basic methods. One is sensitivity analysis and one is post-optimal analysis. तो दोनों के जरिए जिस तरह भी आप चाहें जो है evaluation करते हैं. And then you have trade space exploration. What is trade space exploration or DOE? Any ideas? Trade space exploration. What is trade space? Trade space क्या होती है? Trade space exploration. State of the art plus trade space is basically your design space plus extension possible in design space. This is trade space. State of the art meaning कि आपकी एक design space थी. What was design space? Design space was this. This was design space. This is your feasible region. For feasible region, that is design space. Trade space is that your design space plus extensions which are possible in your design space through the use of the latest techniques or latest tools, or you want to explore beyond your design space. That is trade space. Okay, so यहाँ this is the room for future research. यहाँ future research आप इसको जब कपल इसके साथ करते हो algorithms को, so you are actually entering trade space exploration, degree of exploration, DOE stands for degree of exploration, कि कहाँ तक आप इसको explore मज़ीद कर सकते हो, कहाँ तक exploit मज़ीद कर सकते हो अपने algorithms को, different variables add करके, different other things add करके. So this is known as trade space exploration. So you don't couple it with trade space all the time. लेकिन for research people, this is the domain, this is the area. जब आप algorithms को इसके साथ couple करते हो, you get new avenues for further exploration. So this is the whole optimization model of a system. अगर आपने system को optimize करना है. Question?
Heuristic techniques में भी आप
जी, heuristic techniques. SA and GA. GA stands for genetic algorithms. And SA stands for I've forgotten. I'll just check SA. I've forgotten what does SA means. But GA stands for genetic algorithms. I've forgotten what is SA. Just nikal gaya. Okay, so this is the whole optimization model. You have inputs and you have remember objective function is an output. You see, objective function is an output. It is not an input. Your design variables are inputs, and as a result of this model you are getting an objective vector or an objective function, and it is an iterative process. It will go on and on. ऐसा नहीं कि एक दफा रुक जाएगा, ये चलता चला जाएगा. It will actually keep on moving and keep on improving. ISO performance. What is ISO performance? ISO performance is that particular area or domain in which your rate of performance is getting constant, or your KPIs are getting constant. KPIs are key performance indicators. So once your KPIs or key performance indicators, they are giving you constant readings, and then they are giving you stable readings, that is ISO performance. Okay.
Sensitivity analysis output के बाद
Sir, output objective function की आई ना, तो you can couple it with this whole module as well. एक तरफ तो काम हो रहा होगा आपका, एक तरफ तो आपका जो ऑप्टिमाइज़र है वो ये काम कर रहा होगा, लेकिन दूसरी तरफ आप इस इनपुट को, इस ऑप्टिमाइज़र के इनपुट को अगर कपल करते हैं इस मॉड्यूल के साथ, तो आउटपुट भी इवैल्यूएट हो रही होगी. सेंसिटिविटी एनालिसिस क्या होता था? सेंसिटिविटी एनालिसिस होता है कि विदाउट चेंजिंग द ऑब्जेक्टिव कंस्ट्रेंट्स आप बाकी सारी चीज़ों का एनालिसिस कर रहे हैं विदाउट चेंजिंग द कंस्ट्रेंट्स. ठीक है, राइट एंड लेफ्ट ऑफ द कंस्ट्रेंट, राइट एंड लेफ्ट ऑफ द रिजल्ट, आप सारी चीज़ें देखना चाह रहे हो. दैट इज सेंसिटिव एनालिसिस. सो आप साथ साथ कर रहे होते हो, जो रिजल्ट आ रहा होता है उसके साथ साथ आप सेंसिटिव एनालिसिस कर रहे होते हो, और उसके परफॉर्मेंस इंडिकेटर्स बना रहे होते हो और देख रहे होते हो कि कहाँ तक आपने परफॉर्मेंस के लिहाज से जाना है. ओके, राइट. सो एग्जाम्पल्स, फॉर एग्जाम्पल aerodynamic optimization of a wing. So you see what are the performance constraints and what is the objective function, and how these constraints are met in order to design a simple wing or aerodynamic design optimization of a wing. कुछ मैंने इसमें दिखाए, there are many, but I have just shown very few geometric constraints and performance constraints. Okay, so now this is what you have to do. I think syntax थोड़ा सा कम हो गया, but I'll just read that out. You have to select one engineering system. This is your second assignment. आपने कोई एक सिस्टम सेलेक्ट करना है, इंजीनियरिंग सिस्टम, वेरी सिंपल इंजीनियरिंग. आई विल गिव यू एग्जांपल. मेरे पास एग्जांपल है, वो भी आपको देखूंगा. सेलेक्ट वन इंजीनियरिंग सिस्टम एंड डिफाइन in as few words as possible the purpose of mission of the system and what does it do. क्योंकि अब हम सिस्टम लेवल ऑप्टिमाइजेशन की बात कर रहे हैं. Define your system requirements. Identify at least 5 subsystems required by your system and indicate how these subsystems interact or communicate with each other. ठीक है, उसी सिस्टम के अंदर आपने देखना है कि 5 सबसिस्टम्स हो, और आपने देखना है कि how those subsystems are interacting or communicating with each other. Decompose the system and the subsystems into objective function, design variable, constraints and performance parameters. Okay, so you have to decompose your system into subsystems, और हर subsystem को you have to define the objective function, design variable, constraints and performance parameters. लेट मी गिव यू एन एग्जांपल. वो आपके लिए इट विल बी गुड कि अगर आप उसको देखते हैं तो यू कैन एक्चुअली सी कि किस तरह इसको करना है. राइट नाउ आई एम वर्किंग ऑन अ टोस्टर. ऑन अ टोस्टर.
Toaster.
या. सो यू सी मैं यहाँ तक पहुँचा हूँ, इससे आगे काम आप लिए खुद करेंगे. So I'll just give you how to which extent I have reached, and then you can actually further this, or you can develop your own thing if you want. Let me 100% पे आ जाएगा. नज़र आ रहा है आपको? नहीं आ रहा. 200 देखते हैं. आ जाएगा. Okay, yes. So I have started working on a toaster. So you can see that how I am trying to design this. So I have introduced the system. So the system chosen for this assignment is an electric toaster. Its primary function is to heat breads and give sustainable output through its product life cycle. Toaster characterizes heating appliances. So now the mission. So I have given a mission as well. Their function is to develop sufficient heat near a slice of bread to heat and toast it. So you can actually select a very simple system, not a very complex system. So then I have actually devised subsystems. There are various subsystems, but I have taken a pop-up toaster. So in a pop-up toaster you have the heating system, the manual carriage system for loading and unloading, the waste cum removal system जो ट्रे होती है नीचे, the fail safe system for prevention of overheating and electric shocks, अगर पानी पड़ जाए तो fail system fuse है नहीं है fuse etc. The indication system for the operator to know and change various temperature settings जो thermostat होता है. So how systems interact with each other. This is how a system this is the functioning of the toaster, the whole functioning of a toaster. How a slice of bread is placed in a slot and how it is heated etc etc etc. I have also given the source भी मैं साथ साथ दे रहा हूँ. You can take it as a reference. ये reference है सिर्फ. So this is my own research, but you can take it as a reference. इसको मैंने करना है. Development of objective function, decision variables and constraints. So now I have actually developed two of the objective functions. So the interaction between the starting temperatures and the current. So I have developed some of the constraints, the temperature constraints and the current constraints. Then I have evaluated some of the performance parameters for the toaster. And then I have actually gone to develop some of the objective functions. So यहाँ तक मैंने काम कर लिया है. So I hope that it is going to be a good research or publishable हो जाएगी. So this is the complete model. It is not a complete model. I am still working on it. So resistance के हवाले से. Sir?
How you have come up to this resistance?
ये this is from the Ohm's law and the power laws etc. And the resistance is given by this is the standard equation of the resistance ना. ये आपको कहीं भी मिल जाती है with temperature coefficient and coefficient resistivity etc. So I have given the sources. You can check in those sources as well. So the aim was to actually decompose this simple system into various subsystems and to see how the various subsystems interact with each other. So you can pick your own examples. This is my example on which I am currently working on. तो इसमें मैं काम करता रहूँगा. But you can pick up your own examples. But the aim was, or aim is of this assignment, is to do this. You have to select a system, decompose it into various subsystems, at least 5, and then you have to define the objective function, the design variables, constraints and performance parameters for each subsystem. और फिर आप ये देखें कि उस subsystem को आप कैसे holistic systems के मॉडल में चेंज कर सकते हैं. What are those parameters और constraints जो कि कॉमन है, जिनके ज़रिए आप जंप कर सकते हो from one subsystem to another subsystem और लिंक कर सकते हो एक subsystem को दूसरे subsystem के साथ. Those linking constraints or those linking parameters are very important, क्योंकि उसी से फिर आपकी holistic मॉडल बनेगा सारे सिस्टम का. So this is your second assignment. I actually मेरा लेक्चर लंबा था but वो आ गए निशान साहब. मैंने शॉर्ट किया लेक्चर को because of our guest lecture. So this was of today. This was optimization and multidisciplinary design optimization covered. After the break of Zohar, we will invite our first guest lecturer, Mr. Zishan. So he'll be taking you to another domain, and that domain is actually of quality. And he'll be talking about a technique known as QFD, quality function deployment. और बड़ा practical उनका experience है, and he has worked on QFD in PTCL. So he is having loads and loads of experience of QFD in PTCL. तो we'll request him to come, और हम उनसे कहेंगे कि आपको आके अपना experience share करें आपके साथ. So on this account we end this short lecture, and we'll continue after Zohar break. Thank you.